Thank you very much. So, here's an image that everybody should know. If you don't know about it, then you should probably go out to the bookstores and get it. It's inherently difficult to find Waldo, and that's what's fun about this. That's why people flip through page after page of this noise of image looking for Waldo. By now, maybe a few of you have found it. I heard a couple people say they found it. Yes, he's up in I think the top left here. But if you asked a computer to do this, it probably would have been able to do this pretty immediately. I mean, it would have been able to look for this image of this guy with this red and white shirt and these blue pants and be able to automate the system of sifting through as many pages as you wanted to pump through it and looking for Waldo pretty aggressively. That's not very fun, but it's, massive data processing, and they can do that. But here's another kind of image that is also very exciting, and an image that was taken by Mark Payne from the Mail on Sunday recently that got very viral and a lot of excitement. If you asked a computer to tell you what was most interesting about this image, it would probably focus in on that golf ball flying right at your face, and it would do so well because that's probably the most unique feature in that image. If you asked it to look for something just weird, that's probably what it would pick. But when you asked the public, when it went viral on the internet, and the public said what was really interesting about this image, it was that guy right there. So, yes. And now every one of you can identify with knowing that that guy is what's unique about this image. But even if you ask a computer today to say, what is this? It probably wouldn't be able to say, look for that weird thing. And how do you automate looking for weird things in massive amounts of images? That's kind of what we're going to be talking about today. When you have massive data sets, you try to automate the processing of these. And when you try to automate the processing of these, you look to computers. And sometimes computers are limited because you have to have predefined quantifiers. You have to have that photo of Waldo. You can't necessarily have this just out there idea what's weird. But when you ask a human brain, you can quickly identify what is weird. You don't have to be predefined. We've had our entire lives to understand, through context, through understanding what's out there, through everything that we've seen, gaining an understanding of what we think is weird, what we think is beautiful, what we think is sad, what we think is happy. These things you can't yet train a computer to do. But looking at thousands and thousands of Waldos or this funny-looking guy with a cigar may be fun, but it's not something that everybody wants to do. So we have to find a way of combining maybe many minds, looking at many minds connected together. And while we're all in this room thinking about these things today, we're all connected, but this is only a brief moment in time. You don't really spend a lot of time afterwards being able to process data. If I asked everybody here to go home with a packet of 10,000 images of where's Waldo and tell me, where are all the Waldos, at the end of the day, I don't think I would get that many results back because everybody would get bored. But the internet's allowing us to do this kind of thing in a new way. And minds are starting to connect over the internet for specific challenges, specific things. We all go to specific sites together. We all go and follow specific movements together. But maybe we can also start looking at specific problems together. This is the idea of crowdsourcing. Can we find a spinning galaxy like they do in Galaxy Zoo? Can we look for a lost explorer like when Steve Fawcett went missing? My problem is that I have over 85,000 images of ultra-high resolution satellite imagery of an area that not many people have gone to, but actually everybody is sort of linked to. An area so forbidden, it hasn't been explored for over 800 years, an area of northern Mongolia that is where we find a lot of the roots of the changes that occurred not only in the 13th century that changed the way in which our modern world is, but also predating this back to what people also believe might be the launching pad of our migration into the New World. In fact, the Genographic Project, which did DNA samples on hundreds of thousands of people, showed that it's possible that maybe 1 in every 200 men through their paternal lineage are genetically related to Genghis Khan. So that means that a couple of you guys are, the kings of Mongolia. But this beautiful, amazing landscape full of cultural heritage and natural beauty is under a new threat. They found the world's largest copper mines. They've got companies like Ivanhoe and Rio Tinto going through and staking out land now, exploring, prospecting for what's under the earth, what can be used for a resource that we can consume today and make a profit off of. Well, while we need those materials, we also need to remember that we have this cultural heritage there that we should try to preserve, we should try to map. And maybe the satellite imagery, all these little bits of images, can help me find those in bulk, do a big survey. And if we do find those kinds of things, maybe we can protect them. Maybe we can understand more about this cultural heritage that originated up in northern Mongolia that's affected all of us and we should really know about. This is ultra-high resolution satellite imagery produced by the GeoEye-1, given to us by the GeoEye Foundation. And when you look closer at specific locations, you can start to make out things like this. A modern structure, a river, a couple of roads, and then these weird little things up there. What is that? I couldn't tell a computer to look for this before because I really didn't know that that was going to be there. But when you look at that, it's very obvious. So we created a crowdsourcing platform and we hosted it on nationalgeographic.com. It was built with a collaboration of UCSD research scientists, a group called Digitar, and of course National Geographic Digital Media, which is an amazing group of people. And we allowed people over the summer to go and mark specific sites that they thought were roads, rivers, modern structures, and maybe these other things that we don't quite know. We wanted to be able to show people what they saw, to incentivize them to think like a collective mind. So after they marked these things, they would see what other people around them had said about the same image and start to gain this collective intelligence, this idea of thinking like the crowd to solve a problem. We would then give feedback in the form of a blog or an update from the field. The idea was that we would take all that data, we would visualize it, distill this information, go into the field, check it out, and in real time tell the public what they saw, and see if we can start shifting the way in which people are doing the data analysis, getting more and more collectively intelligent. We collected more and more data over the beginning of the summer. We started to find these lines, like these red lines here. Those are roads that the public is starting to mark. You can see the map is starting to be laid out. These green dots are different anomalies that are just question marks. Over the course of 2 months, we collected over 1.18 million tags from the public, which means a lot of noise, okay? I've just taken 85,000 images and turned it into 1.18 million bits of noise, and it's like, oh, wow, okay, good. But when you start to distill that information and look for clusters, like for example, this cluster here in the center there, that yellow thing that defines what people thought was an ancient structure, we get very excited and we start looking in detail ourselves. What is that? And sometimes you get very excited and then you look and you're waiting for this moment and you realize it's just sheep. Oh man, it's that's too bad, right? But other times, there's a lot of sheep there, but that's a good thing. But other times you would see a mark these marks behind you, and you take a closer look and you start to find more and more of these strange anomalies that you can't really define. So we took our team into the field. Over the last couple of years, we've had a collaboration with the Mongolian Academy of Science to do these types of surveys, and we've been moving through across a massive landscape on horseback, on foot, exploring every single area that we can possibly think of that are being guided to us from the crowd, from you guys actually participating online or are physically directing us in real time on the ground. And we start to find things like this rectangular rocky shape here. This is actually a Bronze Age burial mound dating back 3,000 years. We find other features like this rectangular shape here, this deer stone here, which the public had picked out, and we couldn't see it when we looked at the satellite image. We were like, well, that's just a dot. Why would we go? It's going to be one sheep, not a group of sheep. Why would we go and check it out? But it turned out it was this ancient monolith, this standing stone that represents a rich heritage that we belong to. This is an aerial image of a large Bronze Age series of burials, and the hard thing to see here is directly above me here is actually a looted tomb that was just recently looted, and it just kind of shows you this new age of thinking where we can people are starting to look towards exploiting this stuff, and we really should try to preserve these types of things. Well, the public is getting this information at random, and they're not able to rebuild these images into specific tiles, so they can't actually see where they are. They wouldn't be able to do this. This was somebody locally who just went there and looted that site, so we're trying to prevent that. And we took this image with what we call the octocopter, an 8-blade helicopter, which crashed a lot, but it was really good too. It did some pretty good stuff. And over the course of 2 months, we didn't uncover, everything was non-invasive. We found and identified and mapped over 55 burial sites ranging over 3,000 years of cultural heritage in a landscape that is quickly being threatened by mining, and we're now trying to do whatever we can to try to use this map to preserve this cultural heritage. So we had a crowd, like the crowd we have today, doing incredible things, very simple things, looking at data and telling us where to go. This is kind of our glory shot. This is us on horseback. It's, you know, but it could be anything. You know, I mean, you could imagine looking at other problems, like massive amounts of photos of bees, trying to do bee counts for colony collapse disorder, looking at longliner fishing boats and trying to regulate this illegal type of fishing, you know, looking at something closer to home, California wildfires or other disasters, and trying to map these things in real time from the public. All you really need is data and a problem. Now, what if that data starts coming from you guys, from your iPhones or your mobile devices, and it's geotagged, and you start to able to introduce this data into the system? And what if the crowd then picks the problem or is able to manipulate the system and change it and augment it? Well, then maybe, what if the internet evolves into a collective consciousness? Thank you.